Hello and welcome back. So, this is the continuation of our discussion about the design of experiment for a single factor experiment. So, last time we discussed about the completely randomized design or the CRD. So, another type of complete block design is the randomized complete block design. So, we will discuss this, the analysis of variance, the design procedure is, how to interpret the data, and that's it. Okay, so let's start. So randomized complete block design or the RCBD requires grouping of homogeneous experimental units into blocks. So if we compare this to CRD, so CRD is we don't have the blocking. So each experimental unit will receive equal chance of receiving the treatment. But this time sa randomized complete block design, so every block dapat nag-contain siya dito sa tanan nga treatment. So, nagitay blocking or the replication efficiency. So, each block or replicate contains a complete set of treatment. Randomization of treatment is independently done from block to block. So, for example, if you have a treatment of 1 to 3, so every block, let's say block 1, na yung treatment 1 to 3, block 2, na yung treatment 1 to 3, and block 4, and so on. So, this is how we illustrate the blocking for randomized complete block design. Let's say, again, no, the same example siya for katong previous. So you have a treatment, tulo ka treatment, then you have a replication of 2. This replication will be considered as the block. We have block 1 and block 2. Okay, so sequence number drawn. So for block 1, for replication 1, so dapat na lang kay treatment nga 1 to 3. Then also for block 2. So as you observe, block 1 nag-contain lang siya og 1 to 3. So dili pareha atong sa CRD nga wala ang blocking. So every treatment so perminti gid nga kan pag abot diri treatment 2 treatment 2 treatment 2 treatment 1 ana. But this time every block dapat nag-contain gid siya sa all treatment. So there are 3 treatment man. So block 1 dapat na ang T1, T3 and T2. So but ang iyang arrangement is based yapon sa randomization nga imong buhaton. Then for block 2 also dapat naka-randomization pod ang every treatment as long as that every block will receive all the treatment. So randomization will follow within this block. So what is the advantage of this? So provide more precise result than CRD because we have this blocking efficiency. Then experiment, setup, and analysis are still simple. Then variability in the experimental units can be introduced to widen range of validity of the results. So it's really applicable gid siya class if you're doing a field experiment, no? Or kung naka sa, let's say for agricultural, nag-conduct ka sa kanang plot, naki-plot karon nagtanom ka. So RCBD is really important. So disadvantage, missing observation within the block causes additional computation. So katong ganina, which is katong sa CRD, no, dili ganina. Katong previous nga topic, which is the CRD. Kung naa kay missing value, makakalculate gihapon ka because there are unequal replication gihapon. But wala nato siya gi-show unsaon siya, but you can calculate. But sa RCBD, having a missing value will causes additional computation. Then reduce efficiency is there's a missing observation. So unlike sa CRD nga bisag ma-miss na kay missing value, efficiency will not change. So there are in CRD you have 3 sources of variation. You have in a CRD there are 2, the treatment and the experimental error. And in RCBD you have 3. You have the treatment, the replication or the block, then the experimental variation. So you add the replication and the block variation. So we need to calculate the block efficiency here. Okay, so for example, for analysis of variance for RCBD, I have here an example showing sa ano. Let's say that we try to predict again the yield of let's say a plant, the yield of a plant. Our treatment karon is the number of seeds or the kilogram or the weight of seeds nga gibutang nato sa every hectare. Let's say if atong treatment is nagbutang lang ta og 25, 50, 75, 100, 125, and 150. Now, we want to predict if we want to find if among this treatment karon na ba siya kalahian in terms sa yield. Let's say ang objective nato is kung ang 25 ba nga kung 25 kilogram ra kung ibutang og 50 kilogram nabay kalahian or ang 50 kilogram og 100 kilogram nabay kalahian. Karon we will use a blocking. We have a replication here, replication 1, replication 2, replication 3, and replication 4. For example, in replication 1, all this treatment will be received. In replication 2, all this treatment will be received. So that's the beauty of having this RCBD. Okay, the design procedure is almost the same. The same ragid siya, but there's additional which is the replication total. Treatment total, discuss naman na gyud sa siya, dapat i-total tanan treatment. Then grand total kabalo na pud taon sa pagkuan sa grand total. Ang naad lang nato is ang replication total, which is i-denote nato as R. So from here kani nga table ato siyang buhaton nga inani nga table na. Okay? So atong arrange siya. So we have this treatment here. So nakay replication 1, replication 2, replication 3, and replication 4. Then for treatment total, just add ra ni tanan dere. Add, so you have this total. So on and so forth. Then ang additional lang nato is we have this replication total. Then for grand total, you just add all this treatment total here. Then you can have the grand total. Then for replication total, you just add this value here. The total for replication 1, the total for replication 2, replication 3, and replication 4. This replication is considered also as block. Well, we want to test if there's a significant difference between block 1 and block 2, block 3 and block 2 and block 3, block 3 and block 4, and so on. So that's why we need to calculate the replication total for this for replication. Then grand mean, just add this, then divide by 6. Then you have this 4,960 na grand mean. Okay, again. Then after that, the same process with CRD, construct a analysis of variance table. The same, but the source of variation natay nadungag, which is the replication. So we need to test the efficiency of our replication. Kung nabay effect, the question mo diri is kung gi-blocking nimo siya, nabay effect karon sa imong yield. Mo natong atong kinahanglan nga tan-awon karon for RCBD. Actually class, there are some experiment nga kinahanglan gi-check blocking, especially for field experiment. Okay? So, using this, kabalo naman taon sa pagkuan na natay replication, treatment, experimental error, then the total. Then proceed to pag-calculate sa degrees of freedom. The total DF is the same. It's RT minus 1, which is R is the number of replication, then multiply by the treatment. Okay, so we have 24 minus 1, so you have the total degree of freedom of 23. Then for replication, it's just R, that number of replication, minus 1. So you have 3, treatment the same, T minus 1. Then you have 5. Then error, you have this formula, or you just 23 minus 3 minus 5, which is also equal to 15. But you can also use this formula, R minus T times T minus 1. Then, after that, we need to calculate the correction factor and the difference sum of square. Again, we need to calculate the correction factor, in which kinahanglan siya in order for us to measure the variance or the variance of the every treatment nga ma-measure siya from its mean. Okay? So the same formula for total SS, for treatment SS, the same formula with the CRD. Karon for replication, natin na dungag replication sum of square. Instead nga treatment ng gamitan ang total replication. Katong gi-total nato for R1, R2, and R3, and R4. Sorry. Okay, kani. For R4, R2, R1, R2, R3, and R4. So just square that, divide by T. Just remember lang, pag ang treatment, ato siyang i-divide into replication para makita gid nato kung unsay kalahian sa every treatment sa every replication. Then for replication pod, ato siyang i-divide by treatment para makita nato unsay kalahian sa every replication sa every treatment. So just subtract the correction factor, then you can have the total SS and also the treatment SS and replication SS. Okay, so for correction factor, we already solved the grand total. Just square that, the divide by n, which is n is just equal to r times t. So you have this correction factor here. Then for the total SS, the same procedure. Just squared all the value, measured value, katong ganina, katong tanan, katong 24 kakuan. Just square that, then add, then minus correction factor, then you can have the total SS. Then the next thing to do is to solve for the treatment SS, which is following the same formula katong sa previous nato. Just square all the treatment total. Square all the treatment total, then add, then minus CF, the correction factor, then you have this treatment SS. Then for replication, using this formula, you just need to square all the replication total. Katong sa bottom part, if we will going back here, this data here, kani just squared all these 4, then add, then subtract the result for with the correction factor, then you have this replication SS. Then again, after replication SS, calculate the error SS by just subtracting total SS with treatment SS and replication SS. So just plug and play the we have the data for total SS, treatment, and replication. So we have a replication SS, error SS of 1,658,376. Okay. So after that, we calculate the mean square. So calculating the mean square is just, again, the treatment SS divided by degree of freedom. Just plug and play. Then you can calculate that the treatment MS is 239,666. And for replication SS divided by its degree of freedom, then you can calculate that 648,120. Then the last mean square is for error. So error SS divided by its degree of freedom. Then you have error MS of 110,558. Okay? So after that, we need to calculate the F value. So F value for treatment. So we need to find now the significant difference of every treatment. So we need to find if applying 25 kilogram, 50 kilogram, 75, and so on has a significant difference. Okay? So we need to find if nabay kalahian yun. Nabay kalahian if ang concern ko da, if makita karon sa farmer, or let's say farmer, yeah, we're talking about fields, if makita karon sa farmer nga or sa ay wala may kalahian if ever bisan pag nag-apply ko 25 kg or 50 kg, wala may kalahian sa yield. So dito na lang ko sa 25 kay makatipid pa. So mo na siya atong kinahanglan kung nabay kay kalahian. Wait. So we need to calculate the F value for treatment. So treatment MS divided by error MS. Always yun siya bottom good ang denominator ang error MS. So we have an F value of 2.17. So we need to compare this with our tabulated F value. So, tabulated F value na to, i-compare na to siya. So, with the F1 na to is 5 atong degree of freedom, then for the F2, which is 15. So, by looking at the table, natay 2.90 for at 5%, then at 1% natay 4.56. Okay, so, kaning class, wala na ako ipakita ang table. Wala na ako ipakita ang table. So, you'll be the one who will find this in the table, no? Ako na lang siyang gidiretso. So, 2.90 then 4.56. So, i-compare na to. Atong na-calculate is 2.17. Then, ang atong tabulated is 2.90 to 4.56, which is less than ni siya sa duha. Therefore, not significant. So, ipasabot. Therefore, in terms sa yield di ay walay kalahian kung nag-apply ba ka og 25, 100, 60 nga seeds. Always gid siya nga same ra gyapon. Walay kalahian, wala siya effect. No? Bisan pag ang 25 kg, it means that even though nga ang gi-apply karon is 25 kg lang, sa ang gi-apply sa isa is 150, always gid nga the same ra gyapon siya kuan. Based sa kaning experiment lang. But not all the time gid. So based sa kaning experiment, wala sa treatment. But we have this replication. Kinahanglan nato tanaw gabi, basin day nga kuan na difference ang area nga atong gigamit. Basin day ang kanang sa replication one is mas na kalahian day. So let's test for this replication. So we need to calculate the F value for this replication. So to calculate the F value, just use the replication mean square. Replication mean square divided by error mean square. So we have a value of 5.86. So let's compare this to the tabulated, in which the tabulated is you have the degree of freedom. Ganina, ang gigamit nato sa DF1 is the treatment because we're trying to find the difference between treatment. So karon kay replication man, so the replication degree of freedom po ang atong gamiton, which is 3. Then always gid ang DF2 is error. So based sa table na kay 3.29 then 5.42. Na-change ba? Wala, anong change lagi. 3.42. Okay, so plug in na to. Then let's compare. 5.86 greater than with both 5% and 1%. So therefore, there's a significant difference or the blocking efficiency based sa blocking atong atong replication. There's a significant difference. So therefore, maybe nay factor tingali nga nay kalahian sa field replication 1, replication 2, replication 3 and replication 4. So you need to find that unsa na siya nga unsa ay unsay problema nga na may effect gyud nga gi-effect ang blocking in terms sa yield nga nakuan. But within treatment based sa atong calculation not significant siya, therefore walay effect, the same lang siya even though nga imong apply 25 or 150, the same lang ang yield. So for di lang ta mo go details sa explanation niya, but that's so how you kung mo discuss ka let's say nga pwede ka moingon nga there's no sufficient evidence that the treatment used in the experiment has a significant effect. This has a significant effect to the yield of a certain plant. Okay, so that's how you can. Okay, so that's it. I made what do you call that? An activity. There are 2 problems there. After this video, there's a next page, a link for your activity. So it will also serve as your practice problem for the upcoming major exam for this subject. So that's it, and thank you and goodbye.